I had forgotten that a few times before. The recording was still perfect, but no. So, databases. Do any of you have prior experience with databases before this? Um, Easy? Mm. Yeah. Do you have Nikola Nikolov this year? For, yeah, so in that case, you are at least getting hands-on experience with SQL at least. Um, so databases. We, the old Skynet had a database admin that would manage the MySQL, I think at the time, databases, and that was key because they were using WordPress, which used the database extensively, and is also why it was incredibly hard, and I ended up failing to back things up properly, because there was a lot of stuff squirreled away in the database. Now, almost all the stuff I've got built uses SQLite. So if you've looked at the bot, the Discord bot, the NDAP backend, all that jazz, you will have probably seen the SQLite somewhere in there. And some programs on NixOS use MySQL or PostgreSQL. So SQLite. The SQLite is a single file in a database. It's literally just a single binary file that is managed extremely well. I don't know how it works. It was originally built for, I think, naval operations where they wanted something that just worked, and it kind of went on from there. Might look into popping the history into this slide in the future, but it's a single file, extremely portable, got bindings in almost every language that you want to use it on. Like I'm using it in Rust, no problem. You can use it in JavaScript, Python, C, well, C obviously because it's a C binding normally, and Java even. You can use it in anything, and it just works. It uses a subset of SQL, so there are some things in it that if you try from a normal database, like from Nicola's course, it won't work in SQL. I think it's more the transactions, which is, you may not have gone on to transactions yet, but it's basically where you want two operations to either complete together or fail. You don't want one to work and the other to not work. It's a very nice thing sometimes in SQL, using more advanced SQL. And it is very easy to back up because it's a single file. PostgreSQL and MySQL are full-fledged database servers with roles and permissions and all that jazz. You can also access them remotely over the network because they are a server. They serve data and they fill a purpose. They're full SQL because they can, and sometimes, depending on which one you're on, it can have more than the regular SQL. As far as I know, SQL has an ISO standard, so there's stuff that's expected to be in it, and Post and My go beyond that. And the ones that we have, yes, it is a fantastic one. Yeah, it's far nicer. You can actually shove JSON into PostgreSQL, and it just works. We don't have any document stores on NoSQL databases. An example of that would be a MongoDB, which can work very well if you have it for a specific role. MongoDB works if you just want to dump data in and pull it out later at some time. you aren't confined by schemas, but you aren't confined by schemas. It's like a pro and a con at the same time. So it's not, those servers are not as easy to back up. You normally have to run a command to export the data. So that will be one thing that we will have to look at in the backup tasks. And that's really all I had on the presentation part and the slides. Any questions before I go into database stuff and the actual repos? A what? That sounds wonderfully horrible. Mm. Mm. Oh, that is hilarious. Yeah, so let's start here with the Nixos. So let's go. What would have it? Most of the big services like GitLab, Nextcloud, they all use databases in the backend. I'm trying to see. Oh yes, so for Nextcloud, I'm going back to that later. For Nextcloud, it has a created database locally, which, because we're using Nextcloud, that config does a pile of things in the background. I actually just pop it into the search here. And so we don't really need to think about managing the Nextcloud database because it's done for us, which is really useful because I don't have the expertise to do it really. I'm good enough on genuine stuff, but not really in-depth, configuration and whatnot. So the fact that someone else manages. So in Nextcloud, when you say create locally, it sets up MySQL or PostgreSQL locally, and if I search for that, then the database host will be on this socket, and there we go. And then there's this part here. So remember, NixOS, everything's configured by the configuration essentially. So you can see that services PostgreSQL make if PostgreSQL local is true, and then so there's all this stuff here. Ensures the database is the database name there, the users are there, and the permissions are all set up for that. And this config here manages the database for us, for Nextcloud. That's not really too exciting for us, so I'm gonna hop back to the Discord bot. So you've used the Discord bot, you've gotten the role, whatnot, but there's actually a few tables in it, and it's all defined in the lib.rs for where am I going up? So database init here, we're using a library called SQLX, which allows you to bind to different services like SQLite, or you could do PostgreSQL or other stuff like that. For our purposes, we use SQLite. You can see that's a file locally, and this query is run. So create table if now exists worms. It has these keys, and an index is created for it as well. If you've worked with SQL, that seems really familiar. And you can see that there's a database.db file here. This entire thing here is the database. I won't show the actual tables here on stream. I'm going to show you a different implementation I'm using, which has got non-private data in it. But yeah, you can see that I'm doing the queries here. And when you want to get data out, you pass in the connection to the database, and then you can run queries and get back results. All from just pure software. So you can see select everything from servers where server is equal to question mark, and the question mark is bound to this parameter here, and that's the server ID. And then because we're using Rust, we need a type, so it returns it as type servers, which is a struct essentially. So not really that exciting. It's literally on there as code. If you want to see how database is actually store data in it, I am going to go, yeah, here we go. So this here is from my tool that I made a while ago for the green bus, the M7 Express bus, because I got pissed off of waiting for it. And so you can see it's literally just a normal set of tables. The columns are defined, there's keys in it, just that. It's nothing really special. It's a binary file which neatly formatted to be a database. Oh yeah, and in case you're wondering, there's a plugin for IntelliJ that allows you to just use the database inside the IntelliJ itself. There's probably one for VS Code as well, but I don't know. I haven't used that, so can't tell. Many questions?
No question. It's just an observation. You know, when you were showing your query, I don't know if you ever worked with databases in Java, but there is a library or dependency called JPA, and I find it very interesting because like JPA allows you to create the query from a function name. That's just one of the things.
Yeah, as far as I know, SQLX is a fairly hands-off one where it tries to do as little as possible. It's not really an ORM. ORM is where it's kind of managed entirely for you, and you dump data in, you put it out, and the ORM just manages all the relationships and all that jazz. SQLX is you have to be a bit more hands-on. SQLX, because it's not an ORM. Yeah, that's not really explaining anything. So yeah, it's hands off. It gives you the query, and what it does do is it does bind stuff, and that does really well because you don't ever want to be passing raw input into the database. That just does not work. You're in for a world of pain then. If there are no other questions, I'll probably stop the stream.
Wait, can you go back to the database you had for the bus thing?
Ah, back to the bus one.
Yeah.
So, what about this is curious to you?
Wait, what's the timestamp? Is that like the Unix time or something?
Yeah, it is. Yeah, fairly simple. That was a while ago. I can't remember when. But it's very easy to store time as an integer. So that's what I generally use, because once you have that, you can convert back and forth, because it's just an offset from 1970. So any computer can easily do the calculations and figure out what day it is now. Also allows you to add or minus times depending. Yeah, you can see that I've got the valid timestamp here, which is the timestamp that I think it was run at. Yeah, it was. And then the estimate is the estimated time that it will be arriving. And yeah, the no data was a non-timestamp if I recall. And that was now. It was arriving essentially right then. Yeah, it was these no data ones is why I was making this in the first place. And again, I have it here in a initialization function that just creates the tables if they don't exist and adds an index. Indexes are essential. If you don't have an index, that's another thing that puts you in a world of pain, because your queries are slow for no reason. Have you got onto indexes yet, Easy? Please get on. You would probably know if you got onto it. Yeah, it's No, why are you not going to every lecture? You should be going to every lecture. Because that's a hard module. It seems easy on the surface, but it's hard. And his tests are fucking difficult. Yeah.
Yeah, no, I know that's a fact. Because he'll actually give you an SQL query and he'll ask you what does it mean. Now it sounds easy on paper, but if I give you a nested SQL query which does some data manipulation, I'll keep you up for watch.
Go to lectures and tutorials. Look, Nick is fantastic. If you have a problem, he will help you.